All right. Hello, students. Welcome to this class session. So in this session, we're actually going to be discussing, another part of the textbook, and that is going to be session 7.3. All right. So in 7.3, we're extending our study of integration, but in this case, we're looking at trigonometric substitution. All right, guys. So we're actually going to study trigonometric substitution. Trigonometric substitution. Okay, so let me just provide a theoretical idea of, why this is important, or, the motivation about this, and then we can be able to apply it and solve a couple of problems. Okay. So suppose that we actually want to calculate the area of a circle. Okay. So let's just write this. So calculate the area of a circle. And keep in mind that, of course, for a generic circle in 2 dimensions, this actually, defines. Okay. So we want to calculate this guy using the idea of integral. Okay. So what do we know, guys? Let me just make a sketch. Let me sketch my circle. Okay. So just assume that this is a perfect circle, guys, and, not irregular in any way. So suppose the radius, of course, by defining it in this way, the radius is just going to be a, right? So this is going to be a, this is going to be a negative a, and then this is going to be a. All right, so what do we know? This guy, x squared plus y squared equals a squared. All right, so keep in mind that my area is actually integral from a to b, right? You have f of x dx. Keep in mind, remember, guys, that y is just f of x. All right, so you want to remember this, guys. So, and that means over here, I have to write y as the surrogate of the formula. So that means my y is just going to be plus or minus the square root of a squared minus x squared. Okay, so what do I know, guys? So over here now, my area, in this case, as per this geometry, I'm going to have 2 copies of negative a to a. Then you have the square root of a squared minus x squared dx. Okay, keep that in mind, guys. All right, so what do we do from here, guys? Now, if you think about this, whenever you have, this is going from a negative a to a, I can actually, this guy, I can write this guy, this becomes 4, right? Then you're going from 0 to a, square root of a squared minus s squared dx. Now, question, guys, if I want to solve this integral, I mean, what can I do? Can I just do a u sub of saying, let u equals a squared minus x squared? Is it going to work? Okay, so what do we do? Now, I can tell you what not to do, right? I can tell you what not to do. So we cannot actually use u equals a squared minus x squared. If you try it, guys, it's going to fail. It's really not going to work. Okay, why? I can tell you for free why that's going to fail. Just because if you differentiate this guy, you have du dx is just going to negative 2x dx, right? Okay, and think about it. Whenever you do u sub, what do you expect? You expect that something cancels, right? So, but you have an x here. So, but right in this integrand, there is no x. So that means that's not going to be the way to go. Okay. So, and if you decide to go from this route and say, oh, say x is just plus or minus square root of, it's even going to be more complicated. Okay. All right. So this will lead to, this leads to more complication, or, you know, or I can say it's going to be more difficult. It's going to be still difficult. Okay, so and that's not actually what we want, guys. That's not what we want. So we have to think outside of the box. And that's the idea of the trigonometric substitution, where you use the idea of trigonometry to make, you know, to obtain solutions to integral problems. Okay, so let's go from there, guys. But we can actually try substitution like x equals a sine theta. Now, keep in mind that I just want to talk about the integrand at this case. So this is the integrand a squared minus x squared. Now, if you plug in this x right here, you're just going to have a squared, right? Minus, you're going to have a squared sine squared of theta. Now, this is just like a theoretical idea of what's going on. Okay, it gets more interesting when we actually, you know, do examples, which we're going to do in a couple of minutes. So over here, a squared is common. I can pull out a squared. I'm going to be left with 1 minus sine squared of theta, guys. And this is exactly going to be a square root of cosine squared theta. Now, what is the assumption we're making here, guys? We're assuming that a is positive. Okay, so even if a is negative, it really doesn't matter, right? Because if you square a negative number, it gives you positive. Okay, so whether a is positive or negative, as a matter of fact, it doesn't matter. So I can relax this condition. All right. And then this guy is just going to be a, then absolute value of cosine of theta. Okay, so what do we know, guys? So with this kind of substitution, we see that x is a function of theta, right? So let me just write that down. With this substitution, okay, x is actually a function of. Now you can actually solve the integral with this new guy. Okay, so but let me tell you guys what's going on. Okay, so now generally, instead of making a substitution like we saw that the other time, that we couldn't just have done u equals a squared minus s squared. That's going to be very complicated. So instead of a substitution which is like u equals g of x, we substitute x equals g of t. This is just a general idea, guys. It gets interesting when we do examples. Okay, if you substitute this guy, what happens, guys? So that way, so that your integral of f of x dx. Okay, so keep in mind that you made this kind of substitution. So whenever you see x, replace x with this guy. So this guy becomes f of g of t. But right now you have dx, right? So that's just going to be g prime of t dt. Dx means differentiate this guy with respect to t. So, and of course, you know, dx is just going to be g prime t dt. And this actually has a name. This kind of substitution is called inverse substitution. This kind of substitution is called inverse substitution. Okay, so there are certain conditions that you can place, that you should place on G. Okay, so one of the condition, let me just write it as the rules, or perhaps you can say condition, is that G must have an inverse function. So that means the inverse of G must exist. Okay, so what does this mean actually? So let me write in the parentheses. This means that G must be 1-to-1. Or better still, you know, in more lighter terms, with regards to the classes you guys have taken in the past, so I can just say that, you know, G satisfies the horizontal line test. Okay. Or let me put that O here. Okay. This satisfies the horizontal line test. Okay. Makes sense, guys? All right. So, and of course, G of theta, which is A sine theta that I had the other time, actually is 1-to-1 within the interval, you know, -pi/2 to pi/2. Okay. So we're going to build things around that, and that really, you know, helps us a lot. It's really going to help us a lot to be able to achieve a lot of things. Okay. So let me say, we know that sine of theta is 1-to-1 in the interval -pi/2 to pi/2. Okay. And on that interval, guys, on this interval, -pi/2 to pi/2, cosine of theta is positive. Okay, at least positive, or it could be 0. Okay, so now if we back up a second, guys, you see that this guy, we had this guy. So let me just put this guy in blue. We had this, right? But now we're saying that that guy cannot be negative, right? We say it's non-negative, right? If it's non-negative, what happens? I can drop the absolute value. So that means square root of a squared minus x squared is just going to be a cosine of theta. Right? And remember, what kind of substitution did we make? We made a substitution such that x is a sine theta. So what is dx? Dx, the theta, is just going to be a cosine of theta d theta. Now, let's see the implication of these guys. Okay, so what if my concern is actually to evaluate this kind of integral, I mean. Okay, what happens in this case, guys? Now keep in mind that this first entry is your a. You know, this is like a squared minus s squared. This guy's a constant. So what kind of substitution can I make? In this case now, I will just say that let u, right, equals 4 sine of theta. So in this case, in this example, this is a substitution that I will make, and then I can solve from there. All right. So now, before we go deep into examples, we're not solving this guy yet. I actually want to, give you guys a table that's going to be very helpful when it comes to solving via trigonometric substitutions. Okay, so let me write table of trigonometric substitutions. So we have an expression. What kind of substitution can I make? Okay, that's the next question I want to ask myself. And what identity is going to be helpful? What trigonometric identity is going to be very helpful for me? Okay, so if I have a square root of a squared minus x squared in the integrand, what kind of substitution do I make? I make a substitution such that x equals a sine of theta. But it's safe to know, what interval is theta lying. Okay, theta is between, in this case, theta is between negative pi over 2 and pi over 2. A very helpful identity is 1 minus sine squared theta equals cosine squared of theta. Okay, so what if I have a slightly different one, a squared plus s squared? Take note, the difference between the first guy and this guy is the sign. You have negative on the first guy, now we have a positive. What kind of substitution do I make? I make x equals a tangent of theta. Again, my angle is between, my theta is between negative pi over 2 and pi over 2. What identity is useful or relevant? I have 1 plus tan squared theta equals a secant squared of theta. And then the last one I want to present for you guys here, it's going to be when you have, what if I have x squared minus a squared? In the first two cases, I had a constant coming up first, but what if it's, on the other side right now? So this is going to be, and I have x is a secant of theta. That's the substitution I make. But over here, the theta actually could lie between two different intervals now. Okay, I'm going to show you. Okay, it could lie within 0 and pi over 2, or perhaps it could actually lie between pi and 3 pi over 2. What substitution becomes useful for me here? Secant squared theta minus 1 equals tan squared theta. Okay, so this is a very important table, guys. It's really going to help and make life easy when you're trying to, solve or evaluate integrals, and then you need trigonometric substitutions to do this. All right. So I think we're actually set in motion we're now ready to, do some examples. Okay, so the first example I like to talk about, guys, an example. Okay, so I want to evaluate this integral, square root of 1 minus, in this case, as the x squared dx. Okay, what do I know, guys? Let me just back up a little bit. Now, the first expression is a squared minus x squared. So that means this guy apparently is something like a squared equals 1, right? And that means my a is 1. So what kind of substitution do I make in this case? I'm just going to go ahead and say, let x equals sine of theta, right? Because it says let a, okay, let's go back 1 second. So let x a sine theta, right? But a is 1. So this becomes 1 sine theta. All right. So once I do this, I can move to dx. Dx becomes cosine of theta d theta. Okay, so what else can I do, guys? In this case now, then I can start plugging in stuffs. Now, this is a very basic example. So let me just tilt something a little bit. What if we're actually meant to do something like this? What happens, guys? They look similar, but the difference is this constant 4 that I have right now. So in this case, what do I do, guys? This guy still looks like, it's still like my first expression, a squared minus x squared. Okay, so this first guy still looks like my a squared, and the whole of this guy pretty much looks like my x squared, right? So what do I do? Now take a look, guys. Come here and do integral square root of course, this becomes like 1 squared, because 1 squared is still 1, right? Minus 2x all squared. I'm pretty much just rewriting, right? So let me just write it. This is simple case. Okay, so what do I do here, guys? That's the question. So what I have here, this guy is like my x, right? So that means my substitution is going to be, say, let 2x equals, of course, 1 times sine theta. That means 2x is just sine of theta. And what is x, guys? X is just going to be 1/2 sine theta. So now you're going to plug in x. Okay, so you have 1 minus 2x all squared, right? Dx equals square root of, this guy becomes a 1 minus, okay, so this guy is going to be like a, of course, if x is this guy, what is x squared? X squared is 1/4 sine squared theta. So this is like I have a 4 times 1/4 sine squared theta. Okay, but keep in mind that this is dx, right? So what is dx, guys? That's another thing I need to know. I need to know what dx is. So dx is just going to be 1/2. Differentiate this guy with respect to theta. You have cosine of theta d theta. Okay, so this is times 1/2 cosine of theta d theta. Okay, so I need you guys to pay attention, because you know, at the level of trigonometric substitution, there's a lot you need to do, but it's a very simple process, guys. It's a very simple process. Okay, so let's see what happens after now. All right, so you can just back up 1 second and see that, oh, we're actually in the right part. So what happens, this guy takes off this guy, right? So I'm pretty much left with integral square root of 1 minus sine squared theta. Remember, I still have this guy, okay? But what do I know? 1/2 is a constant. I can pull it up front. Then you have an integral. Keep in mind, I have a square root. Now, what is the identity, guys? Let's back up 1 second. 1 minus sine squared theta is just cosine squared of theta, right? So this is going to be a cosine squared of theta times cosine theta d theta. But remember, in the interval -pi/2 to pi/2, your cosine is positive, okay? At least non-zero. I mean, it could be 0, right? Sorry about that. It could be 0, but non-negative, okay? So this is 1/2 integral. This guy is going to be a cosine of theta times cosine of theta d theta. Okay, so what do I know, guys? This is a 1/2 integral of cosine squared theta d theta. So now So far, so good. I've been able to drive my problem to a point, but I'm still not done. I need to be able to find an answer, okay? But what do I know, guys? Let me write that in red. So recall that cosine squared of theta is actually 1 plus cosine 2 theta over 2. So right now, I'm going to make this substitution. You actually saw things like this in 7.2, trigonometric integrals. So that idea is very useful right now. So this is what we're actually solving. So this guy is a 1/2 integral. Okay, so plug in this guy here. 1 plus cosine of 2 theta over 2 d theta. Okay, so 1/2 is common on the bottom. You can pull it up front. So you have 1/4 integral of 1 plus cosine of 2 theta d theta. Amazing, it's becoming simpler. So now integrate this guy. Remember, you have a 1/4 up front. If you integrate a constant, you have integral of 1 d theta. You just get a theta, right? Plus, when you integrate this guy, let me remind you guys as well, if you have integral of cosine of kx dx, this is just 1 over k sine kx plus c. So we're actually applying this trigonometric idea. So this is just gonna be a 1/2 sine 2 theta, right? Of course, plus c. But are we done here, guys? Not quite. The left-hand side is in terms of x. The right-hand side is in terms of theta. Something doesn't seem right, okay? So then we have to be able to convert. We are going to switch back from theta to x. So now how do we do that, guys? So you want to recall that x equals a sine of theta. But do you remember the SOHCAHTOA? Okay. Sine is actually opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. What about tangent? Opposite divided by adjacent. Okay, so what do I do, guys? That means my sine of theta is just x over a. Okay, so but what is my a in this case, guys? Okay, so I have to be careful. I have to tread carefully. So this is the principle, or this is the idea we're actually applying. But right now, I have to tread carefully and make sure I apply to our problem, to the problem in our context. Okay, so in our context, in our example, we know 2x is just sine of theta, right? So if you write 2x, 2x is the same thing as 2x divided by 1, is that right? So that means my sine of theta is just 2x over 1. That means this guy on the top is my opposite, right? And this guy on the bottom is my hypotenuse. So right now you have to now draw a right angle triangle, okay? The next step is to draw a right angle triangle. Now, let's call this guy our theta, of course. The point, the line with which two angles rest is what we call the adjacent, right? What is the opposite of theta? This guy. So this is a 2x. What is the hypotenuse, the longest side? 1. All right, so I am concerned about the adjacent. How do I find the adjacent? That's my big concern, right? Remember the Pythagoras theorem? Okay, do you remember that, guys? If you do the Pythagoras theorem, this guy is going to be 1 minus 4x squared. Okay, remember the trick, opposite squared plus adjacent squared. Okay, so the opposite is 2x, right? So you have a 2x squared plus, we don't know the adjacent. This is a 1 squared. So that means that the adjacent is just going to be square root of 1 minus 4x squared. And that's why we'll have that. We're almost done, guys, I promise you. Okay, so far so good. We're moving in the right direction. So we now have to go back here and we see, oh, what do I need to do? What do I need to do? What do I need to achieve? Okay, so you have a sine 2 theta, right? But right now, the best you have is your sine theta. Now you have to still think about, so guys, you have to, have your trigonometric substitutions in mind, or trigonometric integrals. You must be able to apply them every time. 1 minus 4x squared dx. When we solve this guy, we actually got a 1/4 theta plus, let me back up a little bit, 1/2 sine 2 theta, right, plus c. But what do we know, guys? Do you guys remember that sine of 2 theta is actually going to be 2 sine theta cosine of theta? So then you apply this guy, okay? That's just from trigonometric, guys. This is calculus 2 class and not a trigonometric class. But this is, this is by when you do sine theta plus theta, how you expand it and everything. That's how it comes to be. So this becomes a 1/4 theta plus, this is a 1/2 times 2 sine of theta cosine of theta plus c. This is exactly 1/4 theta plus 2. You don't have 2 again, my bad. And theta cosine theta plus c. But what is sine theta, guys? Let's go back to our triangle. Oh, we know it's sine theta is just 2x. What about cosine? Okay, so cosine is opposite, right, over hypotenuse. I mean adjacent over hypotenuse. What is the adjacent? Square root of 1 minus 4x squared. What is the hypotenuse? You have 1. Okay, so far so good, guys. We know that my sine theta is just 2x. My cosine of theta is the square root of 1 minus 4x squared. So that means I have accounted for sine theta. I've accounted for cosine of theta. What about theta, guys? What do? I'm going to come here, and theta is just going to be the arc sine. Do you guys remember this from trigonometry? Arc sine of 2x. And then I'm ready to be done. Okay, so this is going to be an integral square root of 1 minus 4x squared dx. And this is a 1/4. Theta is known, okay? I know these guys. Theta is known. That's going to be arc sine 2x plus, what is sine theta? Sine theta is 2x, right? What is cosine theta? Cosine theta is this guy. Oh my God, amazing. Then we're done. We're done, guys. So this way, what you have on the left-hand side is in terms of x, and what you have on the right-hand side is in terms of x. So if you leave your right-hand side in terms of theta, then the job is not complete yet, okay? So, and how do you complete the job? You have to draw your, right angle triangle and be able to ascertain what is sine theta, what is cosine theta, or depending on what problem you're actually solving, okay? Definitely, you can definitely back up a little bit to still look at these ideas, okay? So to just make sure you look at what we just did. All right, so now let's do one more example on this using the idea of this sine kind of substitution. Example, I have integral x over square root of 49 minus x squared dx. How do I handle this, guys? Take a look, guys. This example looks, it looks different from the first one, but essentially, guys, we'll use the same idea. Now, let's back up 1 second to the table, guys. This is a squared, right? Minus x squared. That means the constant comes first, and then you can talk about the variable. Okay, so this is a constant first, and then this is the variable. So what does that mean for us, guys? So let's x equals, now remember it is square root of a squared minus x squared. When this happens, you say let x equals a sine of theta. This is a squared. How do I get a? The square root of this guy. What's the square root of 49? That's 7. So you have 7 sine of theta. Make sense, guys? So if you get your substitution wrong, then every other thing you're doing is going to be incorrect. Okay, so next up, I need to find my dx. Dx, the theta derivative. What is x squared? X squared is 49 sine squared of theta. So I need to make my substitution now. 49 minus x squared dx. This is exactly going to be integral. What is x? 7 sine of theta over, now you have a square root. This is a 49 minus 49 sine squared of theta. What is dx, guys? Dx is just 7 cosine of theta d theta. Now we have to solve in terms of theta, right? So let's see. Now you have to think about a way of simplifying things to make life easy. Okay. Let us see. This is integral. You have a 7 sine theta on the top. You have a 7 sine theta on the top divided by, on the bottom, 49 is common, right? I can pull out 49. So you have a 49 this way, 1 minus sine squared theta. Okay. You write that clearly. Multiply by, you have a 7 cosine of theta d theta. Now, what is the square root of 49? The square root of 49 is 7, right? But what do I know, guys? I know 1 minus sine squared theta is actually cosine squared of theta. Now, when you take the square root of cosine squared of theta, what do you get, guys? You get a cosine of theta. So this guy becomes cosine of theta. Multiplied by 7 cosine of theta d theta. Amazing. So something definitely cancels. So that means this guy takes off this guy. What are you left with? You're left with this guy, this 7. 7 is a constant, pull it up front. Okay, what do I know, guys? If I integrate sine, what do I get? I get the negative cosine, right? Negative 7 cosine of theta plus c. But are we done here, guys? Not quite. We're not done. So remember, I have to set up my right angle triangle. Okay. This guy is my theta. This guy over here is my 90 degrees. Well, what do I know, guys? I know that my x is actually 7 sine of theta. This actually means that my sine theta is just x over 7. I remember when you have sine, opposites, and hypotenuse. So that means this guy is the opposite, and this guy is just the hypotenuse, right? Opposites, hypotenuse. Similarly, you use the idea of the Pythagoras theorem to find the adjacent. If you do that, you're going to get 49 minus x squared. You can actually confirm that, guys. Okay, so I gotta write that a little bit clearly. Yes. Okay, so but I need to switch from theta to x, right? So this is cosine of theta, all right? So go back to your triangle. What is cosine? Adjacent divided by hypotenuse. So that means that way I have square root of 49 minus x squared divided by 7, right? So I have to plug in this cosine over here. So that means that my problem I'm actually solving x over, okay, so let me write that clearly. So you do have an x divided by square root of 49 minus x squared dx. This guy is going to be a negative 7 times, what is cosine? This guy, okay? So I do have a square root of 49 minus x squared divided by 7, then I have a plus c. Okay, so what can you find out, guys? 7 takes off 7. And then we just conclude by saying this guy is just negative square root of 49 minus x squared plus c. Okay, so this is what we get. Okay, that is what we get. Okay, so now let's try, other examples with other possibilities. Now, what we've focused on so far is something that has to do with, sine, and sine. So what if we have a problem that requires a different kind of substitution? So that takes us to another example. Integral 1 divided by x squared. Okay. So guys, do not freak out by how the problem looks like. You have to think about, oh, what is this I know, right? What is what I actually know, or how can I go about it? Now, we see from the table you saw earlier on. Okay, you can back up if you get to this point. You find out that the second guy was that you have one of those with which you had a constant a squared plus x squared under the square roots. And that's exactly what you have on the bottom here. So, and when that happens, remember we said the substitution is a tan of theta. So let me remind you what I'm saying. When you have this type, what do? You say let x equals a tangent of theta. Okay. And that's exactly what we want to do, guys. So solution. So let x equals, in this case now, what is a? A is 2, right? So you have to be careful, guys. A is not 4 because this has to be a squared. 4 is exactly 2 squared. So that's, okay, it should be 2, not a. So I do have a 2 tangent of theta. Okay, you know the drill, guys. Of course, over here, your angle is between negative pi over 2 and pi over 2. What is going to be dx, the theta? Differentiate this guy with respect to theta. Okay, so you get a 2. If you differentiate tan, what do you get, guys? You get a secant squared, theta d theta. But I need x squared. X squared is square this guy. You have a 4 tan squared of theta. Okay, it's getting interesting, guys. Getting interesting. What do we know now? We're good to plug things in, right? So I have a 1 over, this is s squared square root of s squared plus 4 dx, right? So let's plug things in. I have a 1 over, what is x squared? 4 tan squared of theta. I have a square root of 4 tan squared of theta plus 4. What is dx, guys? Dx is 2 secant squared of theta d theta. So now I have to find a way to actually do a lot of simplification and make life easy. This is integral 1 divided by, you have a 4 tan squared of theta. Square root of, this guy's a 4, this guy's a 4. That means 4 is common, right? You can pull out your 4, you have a tan squared theta plus 1. 2 secant theta d theta. Okay, I hope you guys are following these steps one at a time. What do I know, guys? Square root of 4 is 2, right? But this guy is just secant squared of theta, right? But now my concern is square root of secant squared of theta, and that will give me secant theta, right? Provided secant of theta is greater than or equal to 0. Okay? So now let's put things together. So I have a 1 over, you have a 4 tan squared of theta times, over here, from this guy, you get a 2 secant theta divided by 2 secant squared of theta d theta. Can anything cancel? Obviously, this guy takes off this guy. Okay. What else do we realize, guys? This guy takes off 1 copy of this. So that means I have a 1/4. It's a constant, so you can pull it up front. You have an integral secant of theta over tan squared of theta d theta. Okay, so I got to figure out what else can I do? How can I integrate this guy? Okay, so sometimes to solve the problem, you lead to another problem, but there's always going to be a way out. All right, so what do I know, guys? 1/4 integral. Now, remember, guys, that, let me write that guy in red. Remember that secant of theta is just, secant is the inverse of cosine, right? And what is tangent? Tan is just sine divided by cosine, okay? So I'm going to apply these ideas or this. So if your trigonometry is a little bit crude or rusty, guys, I would encourage you to, do a review on trigonometry. So what is secant? This guy is just 1 over, this is cosine of theta multiplied by. Now, in this case, you have the tangent on the bottom. You're going to do change flip, okay? Cosine squared theta over sine squared of theta d theta. All right, so this cosine takes off 1 copy of this. Okay, so let's see where this leads us to, guys. This is a 1/4 integral. You have a cosine theta on the top divided by sine squared theta on the bottom. What do we do? What do we do, guys? It's like, oh, we're moving from one problem to another problem to another problem. But we're almost there, guys. We're almost, okay? So how can you, integrate this guy? Now you can talk about the regular U sub that you know, okay? So you can say let U equals, in this case, that'll be sine theta, because when you differentiate sine, it gives you cosine. So you need something to cancel out. What is my du? The theta, this is going to be cosine theta d theta. I need d theta out by itself. That means my d theta is just going to be du over cosine of theta. Okay. This is a 1/4 integral of, you got a cosine of theta divided by u squared du over cosine of theta. Amazing. This guy cancels this guy. Okay, so if you integrate, what are you left with? I'm left with 1 over u squared du. So if you integrate this guy, what do you get, guys? 1 over 4. Integrate this guy, you're going to get -1 over u, okay, plus c. Now, how is that possible? You have a u to the -2 plus 1 over -2 plus 1, okay? But can I stop here, guys? Not quite. I got to go back to my variable x, okay? So what can I do now? I can definitely, remember, pull up my triangle. But before I do that, guys, I can pull out negative here. Okay, what is u? U is called sine of theta, right? Just sine. Okay. What do I know? Let's remind ourselves, guys. Set up your triangle now. Over here, you have a theta. Over here, you have your 90 degrees, right? But what do I know, guys? I remember we started with x equals 2 tan of theta, right? This means that my tangent of theta is just x over 2. But what is tangent? Okay, TOA. That's the opposite and the adjacent. So that means this guy is my opposite and this guy is actually my adjacent. Opposite, adjacent. The same way, use Pythagoras theorem to find the hypotenuse. So that way you have a s squared plus 2 squared equals the square of the hypotenuse. The hypotenuse is just going to be the square root of s squared plus 2 squared, right? And what is square root of s squared plus 2 squared? That's s squared plus 2 squared is just what? It's 4. Makes sense, guys? Okay, so, but what do I need? I need a sine of theta. I'm going to come back to my triangle. What is sine? Opposite of our hypotenuse, right? So that means my sine of theta is exactly going to be what? This is the opposite. This is the hypotenuse. X over square root of s squared plus 4. So now I'm ready to plug things in. This is the original question I started with. This guy becomes a -1/4 multiplied by. Okay, now this is 1 divided by sine of theta, right? But sine of theta is a fraction. Keep in mind the change flip. So this guy goes to s squared plus 4 over x. Okay, so why is that possible? You have a 1 over sine of theta. This is just 1 divided by x over this guy. Then you just do a change flip, right? And this is just going to be, you got a negative square root of s squared plus 4. 4 times x, what do you get, guys? You get a 4x. Okay, so yeah, this is another way to, to go about integration. S squared divided by this guy. So we're actually learning all this so that you can have more tools in your toolbox. You have a lot of tools in your toolbox, and then you just apply it. You just apply them. Now, we've actually used our sine, we've used our tangent. What about secant? What about secant, guys? We actually also need to do an example with which we can, we can use the secant. Okay, so let us get started. Let's go about it. Okay. Right. In this other example, we have integral dx divided by, you have a square root of s squared minus a squared, provided your a is greater than 0. So you have a condition on the constant in this case. This guy says that the constant is positive. Okay, the constant can be a 1, it can be a 2, or let's pick numbers that have, you know, perfect square roots. It can be a 1, it can be 4, it can be 16, it can be 9, or whatever. But in this case, we really don't know, right? So we're going to go about this guy. What do we do? Now, take a look at this form. Remember, this is the expression, okay? Whenever you have this sort of expression, what kind of substitution do you make? You make x equals a secant squared of theta. Okay, so let's x solution, guys. A secant of theta. Not secant square, my bad. There's no square. There's no square, guys. Okay, so dx the theta is going to be, if you differentiate secant, guys, remember you get a secant tan, okay? Tan theta, d theta. Okay, so what next, guys? What is s squared? A squared secant squared of theta. So now I can put things together, okay? Integral dx over square root of s squared minus a squared. This is integral. What is dx, guys? You got to fix dx on the top. Divided by, you got a square root. What is x squared? X squared is actually a squared secant squared of theta minus a squared. Okay. I just want to write that very well. Interesting, guys. Okay, so when we get to this point, what do we do, guys? Let's remember, this is just a secant theta tan theta d theta over square root of, what is common, guys? A squared is common on the bottom, so I can factor a squared secant squared of theta minus 1. But what do I know? Secant squared of theta minus 1 is actually tan squared of theta. But this is within a square root. Take the square root of this guy. If you take the square root of tan squared of theta, you get a tan theta. Okay. And tan theta is greater than 0. Okay. So this becomes, you got an a on top, secant theta, tan theta, d theta. Remember, if you differentiate, if you take the square root of a squared, what do you get? You get a, right? Interesting. Can anything cancel? Yes, sure. This guy cancels this guy. So what am I left with? Secant theta d theta. If you integrate secant, what do you get, guys? This guy is going to be, if you integrate secant, you get ln of absolute value of secant theta plus tan theta plus c. What have we done here, guys? Not quite, because we need to switch back to x. Okay, to switch back to x, what helps us, guys? We'll set up our right angle triangle. This is theta, this is 90 degrees, right? If I set up this guy, but what do we know, guys? Where did we start from? We started by saying that let x be equal to a secant of theta, okay? But secant of theta is actually x divided by a. Now, but what is secant, guys? Secant is the inverse of cosine. Usually, cosine is adjacent divided by hypotenuse, right? So that means you flip things, okay? If cosine is adjacent divided by hypotenuse, that means secant is actually going to be hypotenuse divided by adjacent, right? So this is secant, right? So this guy is going to be my hypotenuse. This guy is going to be my adjacent. This is a, this is x. Oh. Now, but I need the opposites. What do I do? Do you remember the Pythagoras theorem? Once you do that, you have this guy. Okay, well, in a larger aspects, what is going to be the missing part is already part of the question you're trying to solve. So if you have been taking note of that since we started. Okay, so but what do we need, guys? What do we need? We need tan of theta. So to get tan of theta from this guy, so you have tan of theta, that's opposite divided by adjacent, right? So this guy is square root of x squared minus a squared divided by a. So right now, I'm really ready to plug in things. So ln of, you have the absolute value. What is secant of theta? Remember, secant of theta is just x divided by a plus, what is tan of theta? This guy, square root of x squared minus a squared divided by a plus c. Okay. So in this case, can I take a step further? Definitely I can. Okay, I can actually take a step further. What is common to these guys? A is common on the bottom. So I have a ln 1 over a. You got a x plus square roots of x squared minus a squared. So right now, guys, we want to use our knowledge of, indices, okay? So don't be confused, guys. We're just using what you know. Logarithmic functions, once you have log of, you have a parenthesis x plus y, or maybe x times y. You remember how it splits, right? Okay. So this guy is going to be ln of absolute value x plus square minus a square minus ln of a, right? But a is a positive number from the question. So I can drop this absolute value since a is positive. But keep in mind, guys, that a is a constant. So that means that way, the whole of this guy is also going to be a constant. So call that guy C1, okay? So that's going to be, or let's call it K. This is going to be ln of x plus, got the square root of x squared minus a squared plus K. But what is K? Where K is actually C minus ln of A. Okay? And then that's just what we need, guys. So let me just put it together in so that you guys can see what we did so far. All right, so we do have dx divided by this guy. When we solved it, we got a ln. Of course, a is bigger than 0. X plus, we got the square root of x squared minus a squared plus K. And we already said that my K is C minus ln of A. K is just a constant, guys. It is just a constant. Okay, so that's pretty much how we think about things like this. And if you have those problems as definite integrals, you can just, solve the indefinite integral part, replace your x, and then what else do you do from there? Just, plug in your bounds, and then you're good to go. Okay. All right, so let's actually solve one more example and close this section from there. We want to evaluate this definite integral. Now, which of the expressions do we use here, guys? Let's see who remembers that. We say let x be what, guys? Okay, are you sure? All right, so it's going to be a tan theta. But in this case now, what is a? So a is 1, so I just take off the a, right? Because if you have 1 times tan theta, you still have tan theta, right? But just like before, what is going to be your dx? The derivative, this is going to be secant squared theta d theta. So I can start by dealing with the indefinite integral first. Indefinite integral first. Just to make things easy for myself, right? That's the goal. Okay, watch me, guys. S squared plus 1, then you have dx. So this guy is square root, right? What is x squared? Square this guy, you have a tan squared of theta plus 1. But what is dx? Dx is secant squared of theta d theta, right? All right, so let's see. All right, so what is this guy? Tan squared theta plus 1 gives us secant squared theta, right? Square root of secant squared of theta is just secant of theta, right? So you have a secant theta multiplied by secant squared of theta d theta. Okay. That way, what happens? This guy becomes a secant cube of theta d theta. Okay. So, all right. So now we're here. Okay, so I'm going to leave this guy for you guys to do. However, I'm going to, I'm not going to show details on how I got the final answer. I want you guys to, that's a good practice for you so that you can also be engaged in this learning process. Okay, so if you integrate this guy, you would have a 1/2. Okay, so this is going to be secant of theta tan theta plus ln of, you have a secant of theta tan theta. Okay. Makes sense, guys? All right, so of course, when you get to this point, you can decide to set up your triangle. And if you don't want to set up your triangle, there's still a solution. Okay, so we've been doing a lot of setting up of triangles. So let me avoid it for now, okay, because it's still what you can do. So changing bounds. Remember that you're going from 0 to 1. That was the bound from x, right? So we already said that let x equals tan of theta. That's where we started from, okay? So when x is 0, what happens? That means tan theta equals 0. What does this mean? This means my theta is just 0, right? When x is 1, what happens? That means your tan theta is just 1. And what does this mean? This means theta is just pi over 4. Okay, so what else, guys? What else do we know? We already know the thetas, right? We know the top and the bottom. So that means this guy is just exactly going to be, you can pull out your 1/2 secant of theta tan theta plus ln of secant of theta tan theta. Then you're going from 0 to pi over 4. Okay, so I got to plug in pi over 4, plug in the top, then you subtract the bottom. All right. Now, what is secant of pi over 4? Secant of pi over 4 is just, okay, so let me just go this way. Tan pi over 4, right? Plus ln of, you have a secant of pi over 4, tan of pi over 4. Okay, so that's the top, right? Minus, what about the bottom? The bottom is going to be a secant of 0, tan of 0, right? Plus ln of secant of 0, tan of 0. Okay, so what is secant of pi over 4? That's just square root of 2. This guy is 1. Tan pi over 4 is 1. Plus we have ln of square root of 2, right? Okay. Okay, looks like I'm missing something, guys. This is what I'm missing. Over here, there's going to be a positive here. Okay. All right. So it should be ln of secant theta plus tan of theta. Okay. There's a positive sign here, guys. There's a positive sign here, guys. And there is a positive sign here, guys. Yes. Okay. So for those of you who had actually integrated that guy and like, oh, I didn't get what the professor got. Sorry about that. There's a positive sign. I just fixed it in red. Okay. Positive sign. Okay. So then I have a plus 1. Okay. Because tan of pi over 4 is 1. All right. So far, so good. This guy is the top. Minus, what about the bottom? Secant of 0 is 1. Tan of 0 is 0. Okay. Plus ln of secant of 0 is 1, right? Plus, what is tan of 0? You got a 0. And this guy is going to be 1 multiplied by 0 is a 0, right? The whole of this guy goes to 0. So my final answer becomes 1/2 square root of 2 plus ln of square root of 2 plus 1. Okay, so let me write it in, nicely. Okay, so guys, I know this might be a lot of work. It looks like a lot of work, but the thing is, I would like you to look at, that's why you have this video, right? So you want to look at this video a couple of times to get familiar with the steps. And then whatever problem you have at all, it's very much, obtainable. You can solve it, and then you got to practice some problems too and see what it gives you. So if you use like an online calculator for this guy right now, you get this answer. But, it's always about, oh, how was it gotten? Okay. So, and that's what you're working on. And that's why you're learning these methods. All right. So this is going to be a good place to